Hi friends, welcome back. So today we have another video of FMT. So today we will do one case study and we have some questions and we'll solve their answer. So this video will help you in this deep analysis part, right? So basically this is on the city cycle fuel consumption, that is in mile per gallon, and that need to be predicted in terms of 3 multi-valued discrete and 5 continuous attributes. So let's see how it will work. So this is nothing but our attribute information that is inside our CSV file or the data file. Now the first question is import libraries and load the data file into Python data frame and view top 2 rows, right? So this kind of question you will get, or basically these kind of question we framed just because to make sure or to have the clear idea about what we are doing, right? So we are importing all the necessary libraries: NumPy, Pandas, scikit-learn for linear regression, and we will also use mean square error, right? We are using matplotlib, seaborn. Now we are ignoring the warnings as well. So this is what we are reading our CSV file into pandas data frame. Okay, now click check top few record to get a feel of the data structure. So df.head 2, we will get top 2 rows. Now print the data types of each column and check for missing values if any. Now then perform descriptive analysis, right? So we are dropping the car name and origin column, right? So the car name will be dropped and we are dropping the entire column, right? So that is why we are doing access1 mpg df equals to mpg df dot replace. So we are doing the null value imputation, so replacing all these such symbols with none, right? And then we are dropping all the NAs. If we get the information, so you can see that we have all these column mpg, that is non-null, float 64, cyl, disp, hp, weight, and all these the attribute. Now we are converting the HP column. So you can see the HP column is here of object type. Now we are converting it as df.hp as type to float 64, right? Now we are getting the description of the data frame, or we can say the 5-point summary, so in which we will get mean, standard deviation, minimum, and all these interquartile ranges and the maximum. Now we are plotting a scatter plot. So here you can see that we are getting the mpg df.hp column and the mpg column. Then x label we are labeling as horsepower, y label is mpg. So here you can see that horsepower on mpg, right? Third question is split the data set into training and test sets and fit the model. Also calculate R square. So we are to train test split, first we need to get the xy. So x we are getting as HP, y we are getting as mpg. Splitting x and y into training and test data set by 70 and 30 ratio. So from scikit-learn model selection, train test split we are doing. So x train x test, y train y test, we are doing train test split of 70-30 ratio, right? Where we are passing a random state of any integer number. Now regression model, we are calling the linear regression function here, and now we are fitting the model on x train and y train values, right? So if we print the linear regression model score of x train y train, so we are getting nearly 60% of the score, that is 60% of the score, and this is for trained right, this is for trained data, and for test data again we are getting the 60.5, or here we are getting 60.4 score, right, on our test data. Next question is calculate mean square error for both train and test set. So train MSE, so how we will do that? So first we are calling the regression model predict function of x train, and then we are storing that into predict mpg, and we are printing simply the mean square error of this predict mpg over y train. So here you can see that we are getting the train MSE. So here we are getting train MSE as 23.07, right? So this is nothing but mean square error that we are checking. Similarly on test, so we are here, we will be calling on this x test, right? And similarly we will pass this predict mpg over y test, right? So here in this case we will get this test MSE. So here it is 26.194. Now from sklearn pre-processing, so we are importing polynomial features, right? So we are calling polynomial features of degree 2 including bias equals to false, and we are storing that into poly. So for x poly train, that is for x train, so we are doing poly dot fit transform for x train, right? Similarly we are printing the x polytrain of 0 to 2. So here you can see that the array we are getting like this. So x train of head, if we get head of 2, so here HP you can see that we are getting top 2 head of our x train data. Now x train dot model P2, right? So regression model fit x polytrain over y train. Then we are printing the regression model score of this x polytrain over y train, right? So here we are getting it as 67% near about it. Now again we are calling this polynomial features for degree 3, right? So this time again we are doing the same thing for x train, and again we are calling the regression model dot fit x polytrain on y train and printing it. So here you can see that we are getting 67.76, we can say that, right? Now evaluate the model using cross validation. So we are using here k-fold cross validation. So evaluate using cross validation. Similarly import it from scikit-learn, that is for model selection, right? Now we are seeding it as seed 6. Okay, then we will do k-fold equals to model selection dot k-fold and splits into 20. So model, again we are calling this linear regression. X dot head, if we get these two values of the head. Now result, we are calling again the model selection dot cross validation score of this model, and xy we are passing scoring that the mean squared error, and CV equals to our k-fold, right? If we print this mean square error, you will definitely get the result of this cross validations, right? So next question is apply feature selection method to find which features fits well and do the plotting. So feature selection we call, so again ml extend dot feature selection import sequential feature selector as SFS, right? Again we are having our x and y. So x we are having almost all the column except this mpg, right? And y will contain this mpg. Again doing train test split of 30 and 70 ratio. Now printing train data shape and printing test data shape. So again we will get it x train shape and x test shape. So here you will get the shape of it. If we print normally shape of x, so this is our shape of x. Now build a linear regression to use in feature selection. So we are calling the linear regression function and build step forward feature selection. So SFS1 SFS linear regression k feature equals to 5 forward true, scoring we are doing R2 and CV equals to 5. So if we perform this SFSF, if we perform this FFS, so SFS1 is equal to SFS1 dot fit x train dot values and y train dot values. And if we get the matrix dictionary, so here you can see that for first value, second, third, and all these kind of value you will get accordingly, right? With their CV score, average score, feature names, CI bound, standard deviation, and standard errors, right? Now from ml extend plotting, import plot sequential feature selection as plot SFS. So importing plot matplotlib.pyplot as plt, figure equals to plot SFS. So SFS1 dot get matrix dictionary. So plt dot title sequential forward selection we are calling. So number of feature is this and performance is this. So here you can see that how beautifully the sequential forward selection has been drawn, right? Now which feature, so it is asking basically which feature. So if we get the column list of xtrain dot column, so feature column equals to list of sfs1 dot k features indexes. So if we print it, so we are getting 0 3 5 6 7. So these are the features in our data frames. Now subset column list, so column list of I for I in feature column. So we are doing the for loop here for each column list of I. Now printing a subset column list, so here you can get the respective column, that is CYL, weight, year, origin, and car type. Now next question is now build full model with selected features. So build full model with selected feature, linear regression equals to linear regression dot fit x train subset column list y train, right? So linear regression coffee x equals to true, fit intercept equals to true, and job equals to 1, normalize equals to false. So y train prediction equals to linear regression dot predict x train subset column list. Now if we print the training accuracy on skilled features, so we will get this as 0.830, right? Similarly, if we print the testing accuracy on selected features, so we are getting it as 0.837. Now last but not the least question is build a full model on all features as comparison, right? So we build full model on all features for comparison. So again, taking linear regression, doing the fit on x train and y train, right? So if we print the training accuracy on this selected features, so here we are getting 0.843 because we are using up to 3 float decimals. Similarly, we do for y test prediction, so linear regression dot predict of x test, right? So here we are getting this 0.835. So this was all about this case study for this FMT series. We'll be coming with another few case studies as well, and then we will have our one we can say major project on FMT, since we are like we have like at the end of every module we are having our major project. So you can check the AI project playlist as well. Now, so yeah, this was all about this video. Hope you enjoyed and you got the slight idea on this. Thanks for being with us. Have a good time. Let's meet in the next video. Thanks.